So let's go through a number of the physical network topologies. And the first one I have here is something called the bus. In the bus topology, all of the computers are connected in a straight line. Okay, so I have that illustrated here where we have one straight cable going through the middle, and all the computers are then connected directly to that cable. And I will tell you that this is an older topology and it's an older technology that would use coaxial cabling. You would need to have a terminator on each end of the bus segment. And the reason why is because by default, when a signal gets to the end of a cable, what it does, to be more specific, when an electrical signal gets to the end of a cable, it bounces back. And so the problem is if a computer was to transmit out onto this cable here, it would just go bouncing back and forth, back and forth, back and forth, back and forth until it eventually attenuated away. But that would be a problem because you'd have a lot of collisions going on, and you'd also have a lot of waiting, right? Each computer would be waiting for that one signal to bounce back and forth, back and forth, back and forth, back and forth. So by putting terminators at the end of the cable, and more to be more specific, at each end of the cable, what those terminators do is they absorb the signal. The signal gets to the end of the cable, it gets absorbed, it does not bounce back. When using the bus topology, a single break in the cable would take down the entire network. And the reason why is because, well, if you look at this topology, what happens when you break the cable? Well, now you have an end of a cable that's not terminated. I mean, you might think to yourself, well, if we went ahead and broke the cable, some of the computers may not be able to communicate with other computers, but some are still connected, right? Well, no, because you have an end that's not terminated, and you end up with that bounce. So you end up with collisions and delays. So technically, the network might still work to some extent. You might get some communication, but it definitely would be limited, and it would be extremely limited. Now, that bus topology, like I said, is an old, outdated topology that we don't really see anymore. One that we do see on a very regular basis in today's networks is something called the star topology. Matter of fact, this is the most common topology used in today's local area networks. In the star topology, all of the computers are connected through a central connection point, which I've listed here. I put in parentheses, I put the word hub, although very often these days, instead of it being a hub, it would be something called a switch. And we're going to talk about the differences between a hub and a switch later on in the course. But I can tell you that a switch, just to kind of put it real generically, the switch functions in the same way in the sense that it's that central connection point, but it more efficiently sends communications between the different systems. Okay, just to keep it real simple for right now. I'll explain how when we get to that lesson in the course. One of the nice things about the star topology is that if you had a break in the cable, right, and it's not the cable, it's one of the cables, only that one computer will be unable to communicate with everybody else. All of the rest of the computers can still communicate through the hub or the switch. The only way the entire network goes down is if that central connection point goes down. If that hub or switch goes down, well, then obviously that takes down the entire network. Now I'm going to get to another topology, and I will tell you what, the star topology is what is used 99% of the time in today's local networks. But you need to understand what all these different topologies are. And I will tell you that in a WAN environment, we do see some of these other topologies. But one we have here is something called a ring. In the ring topology, all of the computers are connected in a circular fashion. Data is passed around the ring from computer to computer. So in this particular topology, you have a computer who wants to send, and no matter which computer it wants to send it to, it must send it to the next computer on the ring. And then that computer can pass it along, and the next one passes it along, and eventually it can get to the computer that it was destined for. As a matter of fact, one of the common access methods that was used on a ring network, or I could say more specifically, one of the most commonly used ring networks was something called a token ring network, where it would use something called token passing to appropriately get the data around the ring and make sure it's delivered to the appropriate computer. In a true physical ring topology, a break in the cable would take down the entire network. And the reason why is because data travels around the ring in one direction. If data has to travel around the ring and the ring is broken, data can no longer travel. And what you see on the screen right now is a physical ring, but the reality is that most rings are actually logical rings, and they are physically connected like a star. Okay, so what you have is you have in a token ring network, for instance, you would have computers all connected to a central wiring box, that hub, so to speak. It's a special type of access unit or multi-port access unit or smart multi-part access unit. That's what some of these names were. And all it would do is it would just be a wiring box used so that the computer would pass information along the cable into that box, and it would just be passed right through that box and onto the next computer, who would then pass it back into the box and onto the next computer, and back into the box and onto the next computer. So data would still travel in the form of a ring, as opposed to the true star topology, which we already took a look at. In a true star topology, when data is passed into that central point, depending on whether it's a hub or a switch, data would then be transmitted out to all other computers, or at least to the specific destination computer. In this case, if it was a token ring network, it's only going to pass through the central point, but it's still going to go around the circle to each and every computer. Now, why do we do this? What's the point of using that central wiring box? Well, the benefit was that if you had a break in one of the cables, some of these boxes had the ability to close off that port that the cable was connected into so that the remaining computers could still communicate. Only the one computer would then go down. Okay, so you get that benefit of the star topology. Another network topology we have is something called the mesh topology. The mesh topology is where all of the computers are connected to all other computers, or if not all the other computers, at least there are multiple connections with multiple systems. Now, I'm saying it by using the term computers, but the reality is that the mesh topology usually is not used in direct computer communication. Usually this is used with a bunch of routers, okay? And usually this is going to be in our WAN environment, our wide area network environment. So usually when we have offices around the country or around the globe, we will have a WAN communication line going from one city to another, but we don't want to rely on just that one connection. We want to know that if the connection goes down between one city and another, that those two cities can still communicate with one another. They may have to travel a longer distance. They may have to go through another city to get there, but the data will still get to where it's going. Think of it as if you were flying somewhere, the preference would be to take a nonstop flight. I want to fly from my city to the beautiful city where I'm going on vacation, and I'd like to get there fast, so I want to take a nonstop flight that just, it's a direct line. But sometimes those direct routes aren't easily available, and so we take what's called a connecting flight, where now I have to go through another city along the way. But I still get there, and I still get to enjoy my vacation. Same thing with how the mesh topology works, is we have multiple redundant, fault-tolerant connections between the different cities, so that if you have one connection failure, we have backup routes. Now here I have a terrible illustration of a hybrid network topology. What this illustration is basically supposed to be is a hybrid between a star and a bus. The idea here is you'll see that I have the three hubs representing the three different stars, and then those three hubs are all connected on a bus. It's a terrible drawing because this drawing really makes it look like this is just a star-star topology. And again, I will tell you that in today's world, even what's considered to be the hybrid technologies are usually a hybrid of the same topology. So you do have like a star-star type topology. Okay, but I just want you to understand that there is the capability of using more than one topology together.